In this paper, we present a system that enhances multi-human object interaction data, MHOI data for short, where multiple participants collaboratively interact with a shared object, such as two people moving a table together. Given noisy multi-person HOI data as input, a full body motion with incorrect object contact or motion artifacts, our system enhances the noisy multi-person HOI data by generating plausible finger motions interacting with the object, while generating natural full body motions preserving the original interaction semantics. Even with motions having severe jitter, our system can robustly clean up the noisy motion and generate plausible finger motions. The input motion here shows artifacts on the foot and erroneous contact, while our pipeline cleans up the body motion with natural contact. In this moving barrel example, our pipeline generates hand motion that fits the lid and the rounded side surface. Our system can also be used as a post-processing pipeline for generative models to enhance their generated multi-person HOI motion with artifacts. We demonstrate this capability using the Object Motion-Guided Human Motion Synthesis model. Using the box motion as a conditional input, the model generates the corresponding multi-person HOI motion. However, those motions often show foot skating, inconsistent contact, and noisy poses. Our method produces multi-person HOI data free of such artifacts. The finger motion for grasping and releasing the box is also generated. This is another example of a table moving motion. Our system also supports creating multi-human HOI data using simple keyframe animation. Starting from an object generated with text-to-3D models, the user first defines a small set of keyframes. Here we have 1, 2, 3, 4 keyframes. The full input motion is then generated by interpolating the keyframes. These motions are passed through our pipeline to produce high-quality output motions. This is another example where two people rotate a large chest. We also demonstrate that our pipeline is applicable to multi-person HOI scenarios with 3 or more people, such as 4 people rotating an object, or 3 people lifting up a table. Furthermore, our system can handle both static and dynamic interactions, such as a person sitting on a chair while another person moves the chair away. The input shows artifacts where the body floats above the chair. Our pipeline can refine this motion by enforcing contact with the hip joint and the chair during the refinement process. Our system also serves as a data augmentation pipeline by replacing the original object with other variations during the enhancement process. In this example, the original object is shown in the top left. We create new multi-person HOI data using other types of chairs with different geometries. We can see that plausible hand motions are generated that adapt to the new object geometry. In the chair handover scenario, the full body poses of both the giver and receiver adapt accordingly. we demonstrate the effectiveness of our method on various multi-person HOI data acquired with existing capture methods. First, we test our pipeline with the data captured with existing HMR methods that estimates human motion from monocular videos. From a monocular video recorded multi-person HOI motions, we extract human motion with existing HMR methods and align it with the object coordinate system. The extracted human motions show artifacts, such as foot hovering and unnatural contact. The output multi-person HOI motion shows natural human object contact with finger-level details. This is another example of moving a large box. Second, we test with existing multi-person HOI data from the Core 4D dataset. When the input motion is further degraded with additional synthetic noise, our method can still produce plausible and natural-looking motions. As a baseline, we also compare our results with the data in which real hand motions are captured. Specifically, the finger movements are captured using gloves and integrated with body motion through optimization-based retargeting. Even with this extra capture process, the captured results show that the fingers are not precise and do not make stable contact with the object. On the other hand, our synthesized results show stable and natural-looking grasping. We present ablation studies for each technical component of our pipeline. During the optimization process to generate hand grasp poses, using bounded cylinder space encourages synthesizing grasps that are semantically consistent with the given input motion. Without the cylinder, the generated grasp looks visually plausible, but may semantically be inconsistent. Additionally, this causes the optimized body pose to deviate significantly from the input. Using the hand information from the previous stage and the contact objective enforces plausible contacts with the object. Without the pose objective, the output motion significantly deviates from the input. The interaction graph objective preserves interperson directional relationships. Without it, the pink person shows poses with an unnaturally twisted torso. Adding the collision-free objective effectively improves collision avoidance. Thank you for watching.